TTL Computer II. Today, I have an update for you for the clock PCB, and I'm up to version 2 on the clock PCB. And if you watch my unboxing video, you kind of got a preview of to why I might be doing why I did that. But one thing that I questioned looking at the PCBs that I received from fabrication. They were done perfectly according to the design. But one thing that I noticed was that um, the solder pads on a lot of the components were really small, and some of the through holes were also very small. And I was started to become uncomfortable about those details. Um, since the clock is such a critical component of the system. And besides that, I had something else in the routing, and this is the new design. But you can see here, this is our main oscillator signal, and you can see in this version that that does not go over any other um, traces on the board. Um, and that wasn't the case in the first version of the PC board. If you remember, the clock was over, oscillator was here, and then this clock line kind of ran through here and then down. And it was going over, it was routed over two of the lines over here. And one of those lines is the reset line, and another line is the T clock line. So between those two things, the small solder pads and then the main clock signal running over those other lines, I really decided that I wanted to redo the design on that PC board, redo the trace routing. I kind of didn't want to go through and attempt to solder up all the components, and then even after that do some board testing and find out that the signals weren't good because we were getting crossover between the main clock signal and those other two signals. So rather than going that route, I just bit the bullet and redid the whole board. Now, I've come to find out that the solder, all of the solder pads, which is we're looking at here and here, all of the dimensioning for those pads doesn't really come from the EDA. It comes from the footprint for the component. So, yeah, I said that this whole process, the PC design, was going a lot slower because you have to find the components, a source for the components. Then you have to make sure that, you need 3 models for each component. You need, the symbol for the schematic. You need the footprint for the PCB, layout. And then you also need the 3D model if you want to have that component rendered in the 3D model. So it takes a lot of time to find those things. So not only have to find them, you have to download them in most of the circumstances and load them into EasyEDA. So now on top of that, I have to really inspect all of these footprints and look at the dimensions for them and see if they are in line with those PCB design guidelines that I shared in the community pages. So that's turning out to not be the case. I'm kind of have to updating almost all of the footprints that I pull in. So for all of these solder pads for the ICs, I generally had to lengthen these pads. Instead of making them be circular, I'm making these be oval so that I can increase the width of these pads to have more solder space, but not increasing the width on these, so that there's still a reasonable spacing between the pads. And so I completely redid the routing over. I did not use auto routing. I completely routed this board in version 2 manually. And the layout is much better than it was before. And I also changed the resistor network. The resistor networks are a little bit expensive, and we're only using 4 out of the 8 for this 33 ohm network. So I just replaced this network with 4 individual resistors. And what else? I also straightened out these components, the alignment on these components, and I also reordered the signals on the card edge connector. So I put the N clock, P clock, U clock, and T clock first, and then I put the reset signal. So that'll kind of be standard. So that's kind of standardized for be that way for all of the cards. And what else? I think that was about it. Also, what I did was, as I'm doing more and more, I'm finding out more and more best practices as I do this. So one of the things that I also did was that I added teardrops on the traces. And those are these little expansions here. Instead of just having a straight trace, what it does is when it comes to the pad, it gives these little teardrop extensions. So what that does is that makes a better connection to the pad, and makes that the connection be stronger. And it also better allows for, if the drill in the fabrication process is not exactly on center, since we're increasing the surface area there of the pad, it just gives us a little bit more tolerance in handling if the pad drill bit is not exactly on center, so that we still get a good pad and good adherence with the trace. Okay, so I think that's kind of everything that I did on version 2. But that is off the fabrication, and I should be getting the boards back in about 2 more days, and then I will be jumping right on to starting to populate the board with these components. And then I'm pretty far along on the testing jig as well, and expect that to be our next video, and we'll go over exactly my approach for the testing jig. So that's it. Just a quick update on version 2 of the clock PC board. But again, a lot of learning in this process, and I'm starting to feel a little bit more confident in doing the boards. I also, I said the progress on the test harness board has gone pretty well. Okay, so I think that's it for today. Until next time, thanks for watching.